This is a subject that's pretty close to me. I haven't said it yet. Big secret's out. I'm an electrician in the nuclear field. I work for the Navy on submarines, and so I come in contact with this kind of stuff, in on the day to day, and this is my stuff. Why do you need electrician screwdrivers? Why can't you use a regular screwdriver? Well, let's address that matter. So this is a screwdriver from another video that I reviewed these. The issue with this is it's metal. All of this is conductive, and this back here is conductive. And I'll show you in a bit that, if you have electrical contact here, you're also going to have electrical contact here. So you wouldn't want to use this for anything that's live. But it matters what kind of screwdrivers you have if you need to take some lugs off of wire ends that are still energized. So normally in the field, in my job, the standard is to take standard electrical tape. I like to use Scotch, 3M, the good quality electrical tape because I trust it. It's a little more expensive, but it's totally worth it. It's more pliable. It wraps better around things. This is when you're going for electrical tape, definitely get the good stuff. So the standard is to take this tape and wrap it along the shaft, just like this. We say half wrap, double wrap. So for every time you go around, you should be overlapping your last pass by 1/2 of the thickness of the tape. So you have double thickness wrapping all the way up the shaft and double thickness wrapping all the way down the shaft. So when you're done, you're having 4 thicknesses of the tape all the way down the shaft. So that the only part that's exposed and conductive is the working tip. And there's no conductive parts out here in the handle, so you can safely grab this and stick it into something energized. You still want to be careful that you don't touch anything with your bare, we call them dick skinners. It's your hands. You don't want to touch anything with your hands that's energized, because that can go through your body and, put you in the hospital. Hopefully. Best case scenario, nothing happens. Medium case scenario, you go in the hospital, and worst case scenario, you end up dead. This is your standard screwdriver. To show you, it's got a clear handle. Why it wouldn't really affect you with a standard screwdriver. This is the conductive metal shaft. It goes into the handle and it stops right there. So all of this is plastic, and plastic ideally is non-conductive. Obviously anything will conduct at certain voltages. It'll just break over and it'll be a conductor. But ideally this is non-conductive, and it's okay to touch this part back here on the handle, but if you're touching energized pieces here, if you hit this metal shaft, it's no good. And that's why we insulate it. That's why the insulation on the shaft is important. So these screwdrivers are insulated on the shaft, and that's why they're called electrician screwdrivers. You can see just the tip is exposed, and these are allegedly, and we'll test that in a second with my multimeter, these are insulated along the shaft so that you cannot, if you're working on something here, cannot make a circuit path along the shaft. And then if you look at the handle, there's no conductive parts on here. So the quality of the metal, I don't know. I wouldn't use these for regular screwdriving, ever. I'm pretty sure they aren't very hard tips. You wouldn't really want them to be very hard tips. Most of the you wouldn't need them to. Most of the screws that you're going to be using these on in energized circuits are going to be fairly cheap metal. They're only used to hold down copper or like brass or something lugs on the end of wires. to like a terminal board or something. That's what you would use these for, is like energized terminal boards, and energized panels. Maybe for home use in like a breaker box or something where you couldn't get all the power turned off, or you didn't want to turn all the power off. You could definitely use these in there. It says on the handle, let's try to get a good focus on there. It says they're rated for 1,000 volts and 15 who knows what. I don't. There's no. I would imagine that's amps. 15 amps. 1,000 volts, 15 amps. I'm gonna say. I don't know about the 15. I don't know what that means, but 1,000 V definitely means 1,000 volts. So anything on a U.S. naval submarine, this is good for. We only go up to like 450 volts. So maybe if you're on an aircraft carrier where they do 4160 or whatever it is, you wouldn't want to use these on those bigger panels. Not that you could. These tips are pretty small. I don't think you would have anything rated to that power that has such a small fast. Okay, so I got my multimeter out. A little Craftsman multimeter I picked up at the store a good long time ago. I just had the batteries die on it. This is probably a decade old almost. I think I picked it up in 2006 and it's 2016. I would call this a decade old. All right, so this is I guess a follow-up on another video. We're gonna see if the metal actually runs on these screwdrivers all the way through. I have it on the diode testing mode there, so if it conducts, you can see the little speaker symbol, sound symbol. It will make a noise. It'll make a noise if it's conductive, which means that the metal, if it conducts from here to here, runs through the shaft. So let's try that out. Oh, if I can not get it to move. So you can hear that. It is metal. It's conductive from here to here, so there is metal definitely confirmed running through in some thickness. I don't know, it could be a thin, tiny wire, but it probably isn't, because that would be really hard to manufacture. Harder than just making a straight shaft, at least this size. So there is a shaft definitely going through all the way through here. That is one reason why I would not use these bolstered screwdrivers for electrical work. Because even if I insulated this one all the way up the handle like I did these, this is still going to conduct. And that would be kind of hard to wrap tape around there. I could do it if I really needed to. But this would still be conductive, and I don't want that near my hands. If I'm working on energized gear, it could, contact something else and cause a dangerous situation, and we don't want that. So let's see if I can test resistance. Nope, wrong way. Set it up over here. Okay, so we're on our highest 20 megohms resistance. That's the highest resistance reading. And we're going to take a reading. We'll do a regular screwdriver to see, from the handle to where you hold it. Conductivity. One-handed. Okay, so yeah, we're sufficient. It's pretty much an open. So that's good. So a regular screwdriver, if you don't touch the shaft, you're not getting shocked. You're not going to get shocked. This one, we'll do this tape resistance to the point. Oh, it's so hard. See? Same thing there. It's an open. It's infinite, pretty much. Higher voltage, obviously, anything is a conductor, and it'll get through. So this handle to the shaft that meets the standard of the industrial standard for working on electrical gear, but you're still going to have the shaft exposed, and you don't want this long shaft to be electrically exposed, because it could short out inside the machine and or whatever you're working on. If you're working on energized gear, it'll send a current path straight to ground or something, and too high of a current through too small of a conductor, you're going to have a vaporized plasma ball, and that could burn you severely, if not kill you. And you don't want that. That's why you insulate the shaft mainly. Obviously, if you just keep your hand on this part, you would be okay. But if you touched energized to non-energized, that's not going to be a good situation that you want to be in. So let's test one of these screwdrivers. We can assume that a smaller one is going to be the worst case scenario. Should have the smallest resistance value. So just to make sure that it's on par with industry standards as far as my little Craftsman meter will go, and for home use that's more than adequate. Let's do the shaft. Nah, so hard. I need to get a tripod. So the shaft to the insulated part of the shaft is infinite. So that's good. We'll do the handle where your hand touches. And also infinite. So the worst case screwdriver that Harbor Frieght offers you for electrician usage does meet the industry standard according to this little Craftsman meter, which will definitely read anything that you're going to be worried about inside your household. So if you are looking for a set and you're worried about, getting shocked, you don't know what you're doing, first of all, you should know what you're doing. That's step number one. You should know what you're doing. If you need a set, you're a professional, you're just getting started off as an electrician, or somebody came in your house or your garage and stole all of your tools and you need to start back over. These will get you through your job. Guaranteed, just on the house level. I wouldn't go working on power lines and stuff with these. Unless I did some more testing. I don't have a megohm meter that would shock the crap out of this and tell me exactly what the resistance of the handle is to the tip. So I wouldn't use these on the power lines, but in your household, they're pretty good. Again, 1,000 volts, it says on the handle. Don't know what the 15 is. I would imagine that's amps. Usually that's how it goes, volts and amps rating. These'll get your job done safely, and you won't have to worry as much for doing those types of things. I would recommend this as a buy for that purpose. These were probably I'm gonna say as much as the other screwdrivers, probably $13 for the pack of them. There's 7 of them. Not expensive. Not expensive at all. They're good to have if you're into that kind of thing. If you're not into that kind of thing, you definitely don't know what you're doing. Don't go sticking your hands in something electrical. Call a professional. Don't risk your life. It's not worth it. Live another day. Save the money. Pay somebody who's gonna do it the right way. That's not a risk that you want to take. And that's all that I have to say on that subject. I hope you guys have a safe, especially electrically safe and outstanding day. Thank you, and have a good one.